Welcome back to Bare Metal Machine. In this video I'm going to demonstrate some new features that have been added to the system, and they're all to do with user geometry. The first new definition is for a circle. So if we go to the geometry menu, go down to circles, I've added a circle through 3 points. Okay, so let's define some points and see how it works. Okay, now to demonstrate this we need 3 points. So let me get out of this menu and go back to the main screen so we can see our tool moving around. And just suppose that this position of the spindle meant something. And we're going to go to Menu, Geometry, Points, Tool Position. Right? So it latched the present position of the X and Y axes at that location, and it defined a point, P01. Okay? Now we need 2 more. Okay, let's say that this position meant something to us. So now we're going to go to Menu, Geometry, Points, Tool Position. Now it defined point 2. Okay, 1 more. All right, let's say that this position meant something to us. Okay, Menu, Geometry, Points, Tool Position. Now we got 3 points. Okay, now we go to Menu, Geometry, circles, 3 points. So we want point 1, okay, point 2, okay, point 3. Okay, and there it is. So now go to Modes, Display User Geometry, okay, and there it is. Okay, so now we have this circle is defined. It's a legitimate circle, just like these points that's in the user geometry database. Okay, the next definition is going to be for the endpoints and the midpoint of a line. So take this CAD part model, for instance. So as you know, a line, let's say this one, for instance, it actually, mathematically speaking, goes on forever in either direction, right? But in CAD, it's actually only drawn from some point here to some point here, and that's actually at the tangencies of these arcs, right? So in the CAD database, in other words, the DXF file, it's stored, this line is stored as XY, XY, okay? So it could be useful to us to get at those points, especially given what they mean. For instance, you have some line, and then it is exactly tangent to an arc, and the arc takes off. Well, that point might be interesting to us for further construction. Okay, so we allow you to get at that point and extract it from the database and establish it as a point in the user geometry database. Okay. Now, the other point that could be interesting is the midpoint of a line. So given that, say, this line here goes from this XY to this XY, well, it might also be useful to get at the midpoint. Okay, so we'll allow you to calculate the midpoint of that line. And then, again, you know, once you have that point in the user geometry database, you're free to construct with that point and do anything you want. For instance, you could make a line through that point and perpendicular to this line. You could do all kinds of things once you have that information. So now let me just go over and demonstrate this on the Cartesian display. Now to demonstrate the line endpoint and midpoint feature, let me just define any old arbitrary line on the screen here. I'm going to use the draw feature. Menu, draw, locate first point, hit OK. All right, let's find some other location. Right, hit OK. All right, now we have a line defined, and this line 1, and that's in user geometry. All right, so now we can go to Menu, Geometry, Points. Let's say we want the midpoint of the line. Okay, so midpoint of line, what line? Line 1. Okay, so it defined point 2, right? And there it is. Now, let's say we want the endpoints of the line. So let's go to Points, endpoint of the line. So let's say it's line 1, of course. Now, there's 2 possibilities. There's a point at this end and a point at this end, right? So this end here would be the X large one, The one on the other end would be x small, right? Because it would be the point with the smaller x dimension. It would also be the one with the larger y dimension, whereas this point would be the one with the smaller y dimension. So you can use either one. So let's go x large, right? Because that's going to be this point right here. And there it is. 0.3 is at that end point of that line. Now, let's say we want the other line, or the other point rather. I'm going to go to endpoint, line 1 again, and this time it's going to be, I could have said x small, let's use y large. It's the one with the larger y component. Okay, and there it is. There it is. Okay, so now you got all three of these points defined. And now, of course, we can go, since we have the radar on, we can go into, let's see, point 2 was, which one was which? Point 3, point 4, line 1, point 2. So remember, any entity that's on radar, you can just hit the OK button and it will tell you everything about it. So that point is at x equals this value, y equals this value. Okay? So you can do anything you want with these points now that they're defined. And also notice that when I started this demonstration, I didn't have to load a part model to begin with. Previously, in previous versions, you couldn't just start defining geometry on your own. You always had to have some part model loaded in first. And so that's, you don't have to do that anymore. You can just go power this thing up and just start defining geometry. So let's bring in a model. Here's something that we should be familiar with. So I happen to know that this line here is line 1. So let's define some geometry on it. Let's go menu, geometry, points. Let's do the midpoint. For some reason I needed the midpoint of that line. Line 1 it happens to be. Okay, and there it is. Right. And one more, points, end point of the line. Let's say I wanted this point down here, right at the end of this line, which is exactly at the tangency between this line and that arc. Okay, so I want line 1, and it's going to be not the x large, because that would be this point. It's going to be the x small. It's going to be the point with the smaller x, or the smaller y in this case. Like this point here would be y large. It would be the point with the larger y component. You'll get the hang of how these modifiers work. X small, x large, y small. So we're going to pick the x small point, right? Remember, there's always two solutions whenever it's giving you this choice. Okay, so let's pick x small. And there it is. Point 34 is, let's zoom in on it. There it is. Right there, that's point 34. Get the cutter out of there. See? Okay, so that's that. And once again, once I have this point defined, I'm free to start doing things with it. For instance, like what if I wanted a line passing through that point and perpendicular to this line? Okay, I could just come in here and I could say geometry, lines, let's say through point 34 and perpendicular to line 1. Okay, and there it is. Okay, now remember that when you get back to the main screen here, out of the geometry menu, in order to see the geometry that you've created, you have to be in modes and you have to have display user checked. Okay, that way the geometry that you've defined when you're in the geometry menu will show up out here on the main screen. Okay. And why? Why do I have to turn the geometry on by going into the modes and setting display user? It's actually less about that than it is being able to turn it off. For instance, you might have a bunch of construction geometry that you've done on your part, and once you get the information you want from it, often you want to shut it off so that it's not cluttering up your view, as you're moving your cutter around. So then, you can just go into modes and uncheck display user, and it just goes away. All that user geometry is now off the screen, right? You don't see any of it. So you can turn it on and you can turn it off. Okay? Now, I want to do another example with a circle through 3 points. Now, suppose we had a part like this, some kind of flange, and this is just an example of a part that I'm going to use as a prop in this video. But suppose we had some part like this that we needed to repair. And so it's a flange, and it's got this bolt pattern, and it has this bearing in the middle that needs to be repaired. Just make believe that, you know, maybe this has been welded up because it was a spun bearing or something. So we need to be able to find the center line of where this new bore is going to go. Well, it might be a safe thing to conclude that this feature in the middle is on the same center line as this bolt hole circle, okay? So in that case, all we really need to do is pick up any 3 of these holes and define a circle through 3 points, and the center of that circle is going to be where we need to do our machining to do this repair, okay? All right, I'm going to pick up 3 holes on this flange. I'm going to pick up hole 1, 2, and 3. It's best to have these holes as far apart as possible, you know, like this. These are 120 degrees apart. That's great. It's not a requirement, though. I mean, you could use this one, and this one. It's just that, you know, for the mathematical algorithm that computes the center of the circle to be as accurate as possible, you want the holes as spread out as far as possible, and that'll give you your best result. And so let me just maneuver the tool over to this first hole, okay, and indicate that in. Okay, so here's our first hole, hole number 1. We got that all indicated in just right. Okay, so we got our first hole indicated, so now we go to Menu, Geometry, Points, Tool Position. Okay, so point 1, it just defined our first point, and exit out of here. Now you can't see it because the hole's actually out here someplace, but if we zoom out a little bit, you can see where it is. Zoom out even more. There we go. So now we're in the ballpark. Okay, now I'm gonna pick up the other 2 holes, but I'm not gonna show how I indicated them in or anything like that. I'm just gonna define them. Okay, so there it is. I've got all 3 holes indicated in. Okay, so we got all 3 holes. Remember, all I did was indicate the hole in, and then I went to Geometry, Points, Tool Position. Geometry, Points, Tool Position. Geometry, Points, Tool Position. Now, let's define the circle. Okay, so we're going to Menu, Geometry, Circles, 3 points. It's point 1, point 2, point 3. Okay? So there it is, it's circle 4, and there it is. Now, of course, we can use the radar to discover where the center of that hole actually is. So we can turn radar on, normal, and let's index to that circle, circle 4, there it is, so hit OK. Remember, any entity that's in red, that's on radar, you just hit OK and it'll show you everything about it. And there it is. It's the center line is at x equals this number, y equals this number, and the radius is 4.000. Diameter is 8. So I'm guessing that is an 8-inch bolt circle. Okay. So there it is. Now we simply need to, let's say we were going to bore that hole out. We just navigate with radar to the center of circle 4. And we're off to the races. We can just start machining that feature at the center of that circle, which happens to be that bore that's going to accept, you know, perhaps a new bearing. Now you may be wondering, why does the circle 4, not look like it's on center with the x and y axes? In fact, there's the center right there, that point, right? And it's because before I started this demonstration, all I did to set the origin of the machine was I put the spindle just roughly visibly over the center of that flange. In fact, I actually got it pretty close. And then I set x0, y0 there. But no, the center of the circle is with respect to these 3 points, right? Not the 0, 0 origin of the display. And now we could translate all this geometry, the circle and these points, to the origin, so that, in fact, you know, like if you go to radar, here's where the circle physically is, at these coordinates. Now I could translate all the geometry by these amounts in x and y, and then the circle would appear to be on center with the x and y axes, and in fact it would be at 0, 0. It wouldn't be at these coordinates anymore. Okay, but there's it's not necessary to do that in every case. I can just leave it where it is. I just indicated these holes wherever they happen to be within the machine's coordinate system, and so the center of circle 4, that's God, right? That's what you're going to be working from. So I'm just going to, when I go to machine that hole, I'm going to navigate to the center of circle 4, not to 0, 0. I hope that's clear. Now I wonder, just for kicks, since this hole does exist, and we have defined the center of circle 4 as being, passing through these 3 points, could I navigate now to the center of circle 4 and indicate this bore, and how close would it be? Let's give that a try. All right, now to get to the center of circle 4, so here's the tool location right now. That's where I indicated that last hole. So now we are in radar mode, but we're in user normal mode. I need to switch to holes mode. So radar, holes. Okay, so circle 4, it's on radar, and now I need to navigate the tool to the center of circle 4 by zeroing out dx and dy. Okay, just like navigating to any hole that you're about to drill. Okay. Watch the radar. I'll zero out x first. Okay, now I'll zero out y. It's got to go positive a little bit. Oop, too far. Okay, that's close enough. Okay, so now our spindle is sitting right at the center of C4. So just for kicks, let's indicate that bore and see how close it actually is. But in any case, that's where we would be doing our machining. Say if we were trying to repair that bore, right? We would be at this location, right? Not at 0, 0, but at the center of C4. Okay, so I've navigated the spindle to the center of the circle 4, but then when I got there, I had to tweak X and Y around a little bit to get an acceptable TIR on this on the bore. Now look at the dx and dy on radar. They've been tweaked a little bit. I had to move the machine a little bit off of 0, 0 in order to get a good indicator reading, about 6/10 in x and almost 6/1000 in y. That tells me that the bore in the middle of that flange was never exactly on center with the bolt hole circle. But remember, in this mock example, we wouldn't have had that bore to indicate at all. We would never have learned this. So all we would have to go by is the bolt hole circle and the center of circle 4. So we would navigate to the center of circle 4, dx and dy would be 0, 0, and that's where we would do our machining. I was just curious how close the actual bore was on this part to the original bolt hole circle. So okay, that's an example of how to find a circle through 3 points, and I thank you for watching.